Good morning. Welcome, everyone. Our topic for the day is building a successful hybrid multi cloud strategy. Public clouds are here to stay. This is something that you know. I don't really need to preach to the choir. It's probably only a matter of time till all of your infrastructure and services are on the cloud. Who are the big players here? You know, Amazon and Microsoft are up there, but who is at number three? The answer might surprise you. Avoid the road to perdition. How do you know if hell is where you're headed? Here is a clue: proprietary software and vendor lock in. Don't sweat the big stuff. Is infra better on Azure or AWS? Well, they're more or less the same. Sweat the small stuff. Are my firewalls and gateways configured correctly? You might think that as a CIO, this is beneath my pay grade, but believe me, that's not what the execs at Capital One are thinking right now. The holy grail for any CIO is to talk to the CEO as the owner of a profit center rather than an owner of a cost center. We'll see how recent events at SoftBank, Uber, and WeWork might indicate that there are opportunities for CIOs at old fashioned profit making companies. Now, over the last 10 years, the technology questions that enterprises have been asking themselves changed dramatically. And in those same 10 years, the finance, ops, or business related questions haven't really changed much. Tech moves orders of magnitudes faster than other disciplines. That's both a threat and an opportunity. Now, in the last 10 years, vertical scaling has lost, horizontal scaling has won. The question used to be, should we move to Hadoop? And this sparked off a series of technological and paradigm changes in computing. Now, I know there's a lot of stuff on screen here. Just a note, I won't be talking the slides. I'll share these slides with you, and I'm happy to answer any specific questions that you might have on these topics. The question facing us today is, how do we get real time machine learning predictions? Observe that it is how and not whether. And the answer to this how hinges on getting your data architecture right. And by far, the easiest way to get your data architecture right is using the cloud. This is what our world looks like today. Everyone uses models, almost everyone builds models, and everyone queries data. Organizations are today embracing artificial intelligence and machine learning. They haven't been slow to adopt. But what they've found is that their models don't really live up to the hype. They see that their models have poor performance in production, even though they show spectacularly good performance during training. Now, there can be many reasons for this. It's possible that the models are overfitted. It's possible that data quality is poor. But there is an important underlying reason, and that is the training serving skew. This is when a data follows different code paths in training versus in production. Now, training data is typically historical data. Training data is stored in files somewhere, maybe in databases. It's batch data, and batch data is typically processed meticulously well. Real time data is streaming data. This is the data that you use for predictions. This may be processed in a more ad hoc manner with many shortcuts. Engineers and organizations need to treat all data the same way. The stream is the source of truth. And this requires smart integration of batch and stream data in your architecture so they follow the same code path. They are transformed using the same code. Now, there are different designs you can use to achieve this. The most popular among these are Lambda and Kappa architectures. These are alternative ways to integrate batch and streaming data. This batch streaming integration is key to getting real time insights from machine learning. Now, both of these issues I spoke of earlier, the training serving skew and the correct integration of streaming data for real time ML, can realistically only be solved using cloud platforms today. It's just too much work, too much heavy lifting to do it all yourself. Public clouds make sense from both a business perspective and a tech perspective. Let's discuss the business perspective first. Now, when you speak of moving to the public cloud, when you're choosing between a public cloud and an on premises data center, the choice that you're making is between OPEX and CAPEX. Public clouds tend to be pay as you go, that is, operational expenditures. On premise data centers, you pay upfront. This requires capital expenditure or capex. Now, if you happen to be a startup that is pre IPO, investors often focus on EBITDA for your valuation and just to evaluate how well you're doing. EBITDA, the B stands for before, excludes depreciation, and it so looks better if you're using an on premise data center rather than a cloud. But for large publicly listed companies, stock market investors focus more on net income and free cash flows. Both net income and free cash can take a massive hit if you build huge data centers. So, from the point of view of a large publicly listed company, cloud OPEX is more suitable. Now, over the last 2 decades or so, inflation in most of the world has been very low. In fact, the 30-year bond yield, the US 30-year bond yield, is at or near all-time lows. In times like this, cash is king. Cloud usage makes much more sense. Let's say you had been in an inflationary world like the 1970s, you would want to spend right now rather than later. And that's when big data centers, building your own big data centers would have made more sense, not today. Public clouds also make sense when you talk of spikes and capacity planning. Data volumes today are not often predictable, they tend to be spiky. For example, Alibaba, the large e-commerce retailer in China, has this Singles Day sale, which they hold every year on November 11th. This is the 11/11 sale. They have huge discounts, huge sales in a very short period. In fact, in 2018, they sold goods worth 30 billion in a single day, and the first 10 billion of that came in the first 2 hours. When you need huge spike capacity relative to regular days, clouds are perfect. Clouds are elastic. You can spin up and provision resources on the fly and turn down resources when not needed. Now, just like Alibaba, Flipkart is a large e commerce retailer in India. They had an equivalent of the Singles Day sale called Big Billion Days. They have it every year around October. Their first BBD or Big Billion Day sale was in 2014, where the firm relied on premise data centers. Basically, they had over provisioned, they'd bought a bunch of machines. The site crashed on the big sale day. There were many, many issues. People couldn't log in, they couldn't buy stuff. And the founders the next day had to issue an embarrassing apology in all of the papers. Public clouds make business sense from the point of view of data security as well. Now, Capital One has a very solid reputation as a tech savvy firm. They recently had a data breach. I'm not sure if you read this in the newspapers. This was in July. The news came out in July. The data breach was caused by an ex-employee at AWS. Cap One was one of the first finance firms to move to the cloud, and they were on AWS. This ex-employee basically took advantage of misconfigured network settings between an on-premise DC and a cloud network. Now, this entire breach occurred in the period March to June 2019. And around the same time, this is entirely unrelated, by the way, in April 2019, the US Federal Reserve formally examined and audited the Virginia facility of AWS. Now, the Federal Reserve also happens to be a regulator of Capital One. The examiners came in, they reviewed documents, and they were met with a frosty reception by the AWS guys. The AWS guys weren't really happy to have them there. Now, this entire series of events, the manner in which the breach happened, the fact that it was an AWS issue and not Cap One's issue, gave Capital One some cover. The Cap One execs could justifiably and plausibly deny that they were guilty of sins of omission or commission. Security risks are not going to go away. However, with the cloud platform, you can benefit from fixes made at the platform level. You have platform level protection. Each breach can help others in the same platform get more secure. Public clouds also make sense from the point of view of hiring because public clouds make hiring easier. As technology becomes more central to an organization, it becomes harder and harder to hire specialists for each job. It's very hard to hire for bespoke internal tools, for example. Goldman Sachs uses this tool widely internally. It's called Slang. It's almost impossible for them to hire engineers who have experience in Slang. They have to bring them in and train them in house. What you're really looking for in order to make the most of the data that you have is democratized technology. With democratized machine learning, analysts can build models which a few years ago would have needed data scientists with PhDs. There are some examples here. On the Google Cloud platform, you can build machine learning models using SQL queries, using a technology called BigQuery ML. On Azure, you can build machine learning models with drag and drop visual components. Absolutely no code needed. And this includes data cleaning and preparation. It's not just traditional machine learning models. There's a technology called AutoML available on the GCP, which allows you to build and train deep learning neural network models using little to no code. When you have technologies such as these, democratized ML, you can hire generalists who can build your real time ML in house. Such technologies require elaborate platform support, and that platform support is hard to build, which is why the cloud makes sense. Visualizations today are no longer a simple matter of getting an analyst to build a pretty chart in PowerPoint or Excel. When you're working with, say, Click or Tableau on the cloud, you get powerful interactive visualizations which allow you to see how your data changes in real time. All of these visualizations can be built using simple drag and drop tools. The cloud is what makes this easy. It's not possible to build all of this in house. Public clouds also make sense from a tech perspective because they offer extremely diverse and powerful tools for both compute and storage. Now, you can think of compute offerings on a cloud as lying along a spectrum. At the very left, we have IaaS or infra as a service. This is when you manage your own servers on the cloud, manage your own storage, configure your own networking, your own firewalls, and security. At the other end, you have platform as a service or PaaS offerings. This is where you'll use platform specific tools, whatever the cloud provider offers for scaling, versioning, and deployment. PaaS offerings can often be very, very convenient. It can help you get code to productions faster. Now, all platforms offer compute choices along this spectrum. At the very left, infra as a service end, you have bare metal, where you have complete access to everything, including the machine's hardware. Then you have virtual machine instances, which offer an abstraction over the hardware. When you're at the left end of the spectrum, you have more control over where and how your code runs, more low level access to the underlying operating system and hardware. When you're at the right end of the spectrum, you have hosted apps and serverless functions. This gives you less ops, there is less administrative overhead. You don't have to provision your own machines. You just focus on the code, and the platform takes care of the rest. However, this means you have less control and more platform login. That's key. You'll see that no matter which cloud provider you're on, provided you're on the big three, which are like hyperstack cloud providers, which offer you all features, all platforms offer compute choices along the spectrum. These are the product offerings on AWS along the spectrum. You can see that the product offerings from Azure are more or less the same. And here are the equivalent product offerings on the Google Cloud platform. Now, let's go back to our spectrum of compute choices. Observe that there is an important trade-off that needs to be here. Should you go for more platform support, less administrative overhead, don't have to worry about provisioning, but these involve the use of platform specific tools. And the moment we are talking about platform specific tools, that should get your guard up. Platform specific tools offer convenience, but they lock you into a particular platform. The code that you write is not portable. Or do you choose more control? You have less platform support and you end up using open source tools. Now, there is a balance that you need to get to. There is a balance between embracing platform capabilities and enduring vendor lock in. You need to search for your own sweet spot. And this sweet spot companies have found often involve the use of containers. Containers, Docker containers is probably something that you've heard of. That's the name that is synonymous with containers. That's a containerization technology that's the most popular right now. Containers offer the right trade off between infra as a service and platform as a service offerings. Containers are just a unit of software which basically package your application and all of its dependencies into an isolated unit. Containers are a key technology when you're planning for a hybrid multi cloud world. Now, a single container does not offer scalability, load balancing, fault tolerance, and all of the other bells and whistles that you need when you're building at scale. What you need is a cluster of containers. And once you have a cluster, you need an orchestrator. And that's where Kubernetes comes in. Kubernetes is an orchestration technology for containers. Kubernetes allows you to convert isolated containers running on different hardware into a cluster. Kubernetes allows you to embrace platform capabilities while maintaining the portability and flexibility of your code. And the cool thing about Kubernetes is no matter what cloud platform you're on, you'll find that all of them support Kubernetes. You can even have Kubernetes span networks from your on-premise data center and your cloud network or multi-cloud. In the case of compute, we had 5 main choices that you could make along a spectrum. When it comes to storage, you'll find that the number of choices is very large and it needs a taxonomy like the one you see here on screen. You can see that there are decisions to be made at each step. Now, I won't walk you through this taxonomy. It's there here for your reference, but your choice of storage depends on the kind of data that you have and the kind of querying that you want for your data. You have unstructured data in the form of blobs or binary data like media files or images. You'll go with buckets or persistent disks. If your data is more structured, then you'll have to figure out whether you want SQL querying or no SQL, and that's how you'll make your choice. Now, no matter what storage choice you make, what you need to watch out for is the presence of data silos in your organization. A data silo basically refers to isolated repositories of enterprise data. You might have multiple teams, they're all collecting data for their own benefit. They all store it somewhere where that team itself can access that data, but it may not be available to other teams. Other teams may not even know that that data is available. That is a data silo. Now, data silos come in many forms. They're not really restricted to a particular kind of storage option, but data silos are serious because they can really hamper the productivity of your org. They pose many serious problems. With data silos, you may have the same data stored in multiple locations, which means you have no single source of truth. Plus, you might end up updating one storage location frequently, but not updating another. So you might end up with stale, out of date, or modified data. Plus, if you're storing the same data in multiple places, storage costs can be significant. Also, if you want to audit your data, well, which one do you audit? So once you have so many repositories, you'll see that it's very hard to bring data together. It's hard to connect the dots to gain insights. So you really want to avoid silos. How do you do this? Well, data silos are a big problem, and there are two approaches that you could follow to solve this issue. You either integrate silos or you use something called data lakes. Now, here are the two approaches that you could follow to solving silos. In the first approach, ETL pipelines plus data warehouses, this is the approach that you'll follow if you want to let the silos exist, but you connect up the different bits of data using ETL or extract, transform, load pipelines. This allows you to bring important bits of data together for visualization or analytics. Or you'll go with a data lake setup to eliminate silos entirely. And data lakes are a common offering on the cloud. Azure, AWS, all of them have their own data lake solutions. Now, there are, of course, many other important significant differences between these two approaches. Typically, you'll go with the idea of connecting silos if you have a hybrid cloud. If you have an on-premise private cloud and then you're using a public cloud platform, then you might want some data to remain in one place for, maybe sensitive data. You'll then connect your silos together. But if you're going with a cloud first approach where you're planning to do a one-off migration into the cloud, going with data lakes makes sense. Data lakes allow you to have a single source of truth, They hold raw data in all formats, structured, unstructured, semi-structured data, and they're usually built around blob storage, such as S3 buckets or Azure Blob Storage or Google Cloud Storage buckets. As you can see, public clouds offer very diverse and powerful tools. They are here to stay. Now, there was a Gartner survey where in 2017, only 10% of the large enterprises in America had plans to shut down their data centers and move to the cloud. In 2019, that proportion had risen to 80%. All right. So now we're ready to discuss our major cloud providers and their strengths. Who are they? What are their strengths? Now, when we discuss the different cloud providers, we'll focus on infra as a service market share across cloud platforms from the most recent Gartner report that was released in late July this year. Now, this report focuses on IaaS rather than traditional SaaS offerings, such as those of Salesforce. Most definitions of the cloud market follow this convention, so we'll stick with this as well. So at number one, we had tada. Actually, there was no need for a tada there because we already knew it was AWS. Now, AWS has a market share of almost 50%, 15.5 billion of revenue, up 27%. So they're also growing pretty fast. Amazon started breaking out AWS earnings in April 2015, and their stock has shot up since then. AWS is a cash generating business, very, very profitable, and that cash has powered Amazon's retail business expansion. Amazon's cloud is powerful, it's robust, it's enterprise ready, it's complete, and it makes migration from on premises as simple as possible. But Amazon has many businesses. In some ways, it's like a sprawling 1970s style conglomerate. That means Amazon has many competitors and many adversaries. The obvious one is, of course, Walmart, its main competitor in retail. But let's say you're a traditional grocer and you're looking to move to the cloud. Well, you'll say Amazon owns Whole Foods. You're in logistics and you want to move to the cloud. Amazon has its own logistics unit. In fact, FedEx recently broke off ties with them because of this. Let's say you're in streaming content like Netflix. Amazon has Prime Video. And for this reason, the fact that Amazon competes with everyone, many businesses may prefer not to use AWS. So Amazon is vulnerable to an enemy of my enemy is my friend approach. And that's exactly what Microsoft has been doing. At number two, we have Microsoft Azure. Again, no surprises here. You can see that they had 5 billion of revenue. They're growing much faster than AWS, up 61% from 2017. Their current market share is about 13%. Now, Microsoft dominated PCs and Office software, and they ended up missing many big opportunities. They missed out on search to Google. They missed out on online advertising to Google and Facebook. They missed out on the move to mobile and smartphones to Apple. But finally, Microsoft has seized the opportunity on the cloud, and they've also been re-energized since Satya Nadella took over. Now, Microsoft Azure has built its cloud with a focus on large customers. Microsoft understands the complex needs of enterprises and knows how to work with large corporations. Microsoft has also been very successful in integrating Azure cloud products with technology that enterprises are familiar with. Their cloud offerings are also very, very competitive, very complete and polished. Microsoft has also made a lot of alliances exploiting Amazon's business rivalries. They have an alliance with Walmart, Reliance in India, etc. All right. Who came in at number three? This might surprise you. At number three, we had Alibaba. 2.5 billion of revenue, up 93%, and a market share of almost 8%. Alibaba dominates the cloud market in China. They have an offering for people outside China, countries outside of China, but they're the most widely used within China. So China is a huge, almost US scale market. And because of current US China tensions, it makes Alibaba a natural, safe choice within China. Now, countries like to keep their data close and within their governance limits. It's not surprising that users in China prefer Alibaba. So why would an enterprise choose the Alibaba cloud? Well, they want their data and services to be located in China. They want a relationship with the parent company. Alibaba's offerings are good. They don't compare with Microsoft, Google, and AWS, but they're good. And Alibaba is the fastest growing cloud platform within China. At number four, we have Google. So 1.3 billion of revenue, up 60%, market share of 4%. The GCP, that is the Google Cloud Platform, has kind of struggled to live up to its promise. And their offering is less complete when you compare them with AWS or Azure. Google is mostly preferred by smaller companies who are cloud first and cloud native, as they're called, rather than by large enterprises. And they have good solutions for big data, machine learning, and analytics. Google has also struggled with personnel changes at the top. Now, in November 2018, Google bought in Thomas Kurian, an old hand from Oracle. He spent 20 plus years there as the head of their cloud platform. Previously, it was Diane Green, the founder of VMware, who headed up Google Cloud. Why is this change important? Well, this is symbolic of the increased emphasis on old school B2B sales, of which Oracle is master. So Google are getting serious about the cloud by bringing in Thomas Kurian. Now, here is a little case study of an important offering across cloud platforms, which will demonstrate the little things where the little ways in which Google falls short. So PyTorch is a hot deep learning framework. This was originally from Facebook. It's now an open source framework. It's widely used for building neural network models. Observe how both AWS and Azure have complete offerings for PyTorch. So AWS has a notebook for prototyping, as does Azure. They both have deep learning virtual machines in order to build and train your models. They also offer a high level platform specific estimator to run distributed training on the AWS and Azure cloud. Take a look at GCP's offering. It has a notebook and a deep learning VM. The GCP does not have a high level estimator. And this, in fact, is a problem because with no estimator API, this actually reduces GCP lock in. So if you use PyTorch on AWS or Azure, you'll use platform specific utilities, which are very convenient. It's good for you. It's also actually good for the platform because it locks you into that platform. And this fact that the GCP does not have an estimator at this point in time, maybe they'll add it soon, this is symbolic of how GCP often does not get the boring little details right. At number five, we have IBM. So you can see that its revenue numbers and market share now is quite small. IBM in general is struggling. It's trying to undo its past legacy in software services, but that's proving hard. It's definitely not a momentum player. IBM is mostly preferred by companies who are already using IBM services and they need just a little bit of additional infra on the cloud. They're not really moving to the cloud in a big way. Then there are all of the others: Salesforce, Oracle, Tencent, many small players. Software as a service players like Salesforce and IBM are trying hard to break into cloud infra. They try to build just enough IaaS support to support users of their software as a service platforms, but they're not really hyper stack or complete cloud providers. Each of them tries to build a cloud offering and upsell it to existing customers. And you can see that this has not really worked. This has grown really slowly, only 11% year on year. So here's a quick summary of what we discussed about the different cloud providers. So which one would you choose? If you're in the US or Europe or in Asia other than China, it's a two-horse race. You're likely to choose Amazon or Azure. If you're in China, it's quite likely that you'll go with Alibaba. It's pretty clear here that the big are getting bigger, but there's definitely room for more than one. This is consistent with our initial hypothesis. The world is going to be hybrid and multi-cloud. All right. Avoid the road to perdition. When you're planning for a multi-cloud world, how do you make decisions that avoid locking you into suboptimal choices? The road to hell is paved with breach notices and pricing fine print. As you plan for your hybrid multi-cloud world, make sure that you avoid vendor lock-in. Whatever technology choices you make your choice vendor agnostic and not vendor specific. Choose Spark and not Dataflow, which is on the GCP. Choose Hadoop and not some specific version like Cloudera. Be willing to trade off on ease of use. Platform specific offerings come with a lot of fine print. CIOs have actually understood this and in many instances are voting with their feet. Here's an interesting little story from the real world. I noticed this recently and I was very amused. How back in 2017, Larry Ellison of Oracle said, in the coming year, I expect more of our big customers to migrate their Oracle databases and database applications to the Oracle cloud. 1 year later, Oracle shares drop after JP Morgan downgrades on lost business to Amazon and Microsoft. CIOs have moved their tech infra from vendor specific databases such as Oracle to the public cloud, which has support for general purpose relational database engines. Now, in the days before the cloud, CIOs had to deal with a bunch of nasty facts of life: proprietary hardware, proprietary software, no open interfaces. Hopefully, in a multi cloud world, you won't have to worry about things like draconian licensing, breach notices, or changing the pricing fine print. Breach notices used to be a commonplace practice to get you to buy more from the same vendor. How might you end up with a breach notice? Well, the vendor will license software to you in an intentionally vague manner, and it'll leave several features enabled. And this will lead your developers into using those features that were not included in the license. Now, this was because those features were the easiest alternative. Your developers are trying to build something. The easiest way to get something built was using those features which were not in the license. Then, when your user uses the feature, the company will send you a breach notice. And then it'll send along a team to conduct a software license audit. The user then has to pay a huge fine or sign up for even more punishment. So, what do you need to do? Hopefully, we've left those dark days behind us. We're on the cloud, but even so, make sure that you avoid vendor lock in. And here are some rules of thumb to avoid vendor lock in on the cloud. Avoid PaaS offerings or platform as a service offerings for compute. For example, Elastic Beanstalk on the AWS, App Engine on the GCP. These hosted applications will offer you automatic load balancing, version management, traffic splitting, you name it. It'll be very, very easy and convenient. It'll help you get your prototype up and running at scale quickly. But if you want or need to move your app to another platform, that may involve a full recode. Instead, set up your application using containers and use Kubernetes. You'll find that your applications are more portable. Avoid vendor lock in, avoid platform specific solutions for ML and AI applications. Now, Apache MXNet is an open source framework. It's not really platform specific. However, you'll find that support for it across platforms is not that great. Only AWS offers complete support. If you're looking at multi cloud, it's better you stick to more popular frameworks for deep learning, such as PyTorch and TensorFlow. The same deal with platform specific estimators. We spoke of the PyTorch estimator earlier. You can do a little more work upfront and use PyTorch out of the box, or you can get a little more convenience and use the platform specific estimator. Now, if you do, you might find it very, very difficult to execute your PyTorch code on another cloud platform. So instead, use PyTorch and TensorFlow as is. Now you'll find that each platform, whichever cloud provider you're going with, they have amazing technologies which are easy to use and seem to offer just the right solution for your use case. And these technologies are often proprietary. For example, Cloud Spanner on the GCP will give you asset properties and transaction support with horizontal scaling geographically. So that's really cool. Bigtable on the GCP gives you a columnar store, which is even better than the open source HBase. But these are proprietary technologies. There are no equivalents on other cloud platforms. Stay far away from proprietary formats. Treat them like the plague. Use generic data formats and relational database engines wherever possible. Don't sweat the big stuff. Now, Satisficer versus maximizer. Maybe you've heard these terms before. A satisficer is someone who tries to find a solution that checks all of the boxes and then moves on and tries to make the best of the situation. A maximizer, on the other hand, will try to find the best possible solution out there and won't stop till the global maximum has been found. Now, many studies have shown that satisficers tend to be happier and more successful in business and even in dating. Be a satisficer and not a maximizer, especially when you're making your technology choices. You'll find that whatever your use case, there'll be little difference between big flagship products, and each will have their own areas of strength. AWS versus Azure, there'll be little differences between the two, but they'll be more or less the same. PyTorch versus TensorFlow for deep learning, again, there'll be a few differences, but they'll be able to achieve the same things. Tableau versus Click. Now, this little difference between big flagship products only makes sense with big flagship products. Those terms are important. Don't drop below the top two. Once you do, the product offerings will tend to be AWS or Azure. Don't sweat the big stuff. Don't try to squeeze out the last drop of performance optimization. Now, you might find that the platform as a service offering gives you better performance, easier prototyping, easier productionizing as compared with other services like App Engine on the GCP. But this will lead your developers to platform specific changes and in turn to vendor lock in. Make sure that you're embracing all of the platform's capabilities. Now, lots of tasks that were incredibly complex in the old on premise days now just work. Load balancing and scaling, just a matter of getting your configuration right. You don't have to manage the hardware, routing, or provisioning of resources. Cloud router versus old school router. Cloud routers are so much easier to work with. Disaster recovery. Each platform offers great tools for disaster recovery. Monitoring tools also work cross platform sometimes. For example, Stackdriver on the GCP also works with AWS resources. Or if you're doing machine learning, make sure you leverage transfer learning and pre-trained models. And whatever the and make sure that when you're working with data, you're integrating batch and streaming data. Now, in order to get things right, you need to be worrying about something. If it's not the big stuff, what is it? Well, you need to sweat the small stuff. Little details matter. Security issues and data breaches occur when these little details are overlooked. Cloud based systems are inherently distributed and replicated. Horizontally scaled systems such as these are more complex, they need more coordination and more integration. Now, each point of integration and coordination is a potential point of failure, which is why the small things matter. The Capital One data breach that I referred to earlier was caused due to misconfigured BPCs. And there were also some holes in the metadata service that the AWS cloud platform offered. Now, there was this famous Snap outage about 2 years ago, which was caused due to mishandled memcache misses on the Google Cloud platform. In addition to these, data and privacy concerns will continue to exist. There'll be state sponsored hacking, data for ransom. All of these make costs of failure very, very high. In fact, even if the organization can recover, this can be catastrophic for the career of an individual CIO. How, as a CIO, can you stay on top of these arcane little threats that explode at random? Now, I've been reading a biography of Admiral Nelson recently, the famous hero of the Battle of Trafalgar. His policy: dine with the midshipmen. It's the engineers and analysts in your organization who deal with issues on a daily basis, who really know what can go wrong. Talk to your analysts, talk to your support team, talk to your engineers. Do this often. The specific issues that they encounter will be on the radar screens of the individuals down the hierarchy. Once you hear enough stories across the board, you'll start seeing patterns emerge, and these patterns may be obvious to you, may not be obvious to them. By periodically meeting and listening to them, you as a CIO are much less likely to be blindsided. Listen and learn. Keep your ear to the ground. Mimic Admiral Nelson's strategy. Look for the bad news. Have dinner with the support techs. Ask and analyze the near misses. Find the patterns which elude them. Okay. Once you've got all of these little details right, let's talk about the opportunities that you and your organization have when you're working with public cloud platforms. Today, all the cool problems and cool people seem to be with startups. Tomorrow, old fashioned profit maximizing firms may be back. Here is a recent headline from the Wall Street Journal. AI startup boom raises questions of exaggerated tech savvy. Intriguing, isn't it? I was really curious and I immediately clicked through to the article. So, what exactly is this about? Now, the founder of a very well funded startup claimed to have AI tools that allow people to build apps using virtually no code at all. When the Wall Street Journal dug in, they realized that Engineer.ai does not really use AI to build apps. So, what do? How do the apps get built? Here's what it was. The company relies on human engineers in India and elsewhere to do most of that work. Now, there is lots of anecdotal evidence to suggest that this is not isolated. Why is this happening? Well, a small startup can raise a lot of money, big money, just from prototypes. Established companies, especially companies who are post IPO, are held to a much higher bar. Their product must release, they must gain traction, people should use it, etc. Startups raise huge money in the hundreds of millions of dollars on prototypes or sometimes even just ideas because private markets like to fund moonshots. And there's nothing really bad about this, but it can be taken to an extreme. SoftBank, in particular, has been stuffing capital down the throats of investee companies. All of this could change pretty quickly. It's quite possible that we're looking at a startup funding winter because several tech startups have struggled post IPO. Uber is an example here. Now, WeWork plans to IPO or in the next few months. They're asking for a valuation of $47 billion. Now, there is a company called IWG, which has been in the co working space business far longer than WeWork. It's far bigger and it's actually profitable. WeWork is not profitable. They make a huge amount of loss. Now, IWG is publicly listed and has a valuation which is 4 billion. This is a fraction of WeWork's valuation. Now, clearly, there are different rules for public companies and private companies, and this is probably not sustainable. And this leads us to the opportunities that exist for CIOs. Now, the opportunity exists in some of the trends that we see today. Cloudera was founded in 2008 by ex Google Facebook employees. They built a cloud platform around Hadoop and they recently merged with Hortonworks, but they have been struggling. Mapr, which is a competitor of Cloudera, also did layoffs recently. These firms are being killed by public clouds. So if you are an horizontal player offering a specific, you have just a very specific offering on the cloud, public hyperstack complete clouds, they're basically having you for lunch. But niche vertical enterprise tech is very, very hot. For example, Zoom for video conferencing. So if you have a niche and if you execute software in that niche really well, that can make a lot of money for you. Our IT is so good, let's sell it, firms say. This is no laughing matter because this is how AWS was born. Now, Amazon had a bunch of infrastructure for use during spike period. So they had to build out this infrastructure. They had it lying around. Then it built amazing internal tools to manage that infra. Once they realized they had all this additional capacity, which they didn't need during off sale periods, they started monetizing this additional capacity. And from there came AWS, which is this cash gushing machine. Today, every firm is a tech firm, and there is something that your firm does which is which you can do better than anyone else. And that is your opportunity. Now, this is building your own custom software is only really practical because if you use cloud platforms, otherwise there's too much heavy lifting that you need to do on the infra. The cloud makes 99% of the stuff just work. Then your org can focus on that 1% that you know better than anyone else. You don't need a team to do that 99% in which your organization has no edge. There are other examples here. There is a Toronto based law firm. They developed in house tech to automate document proofreading and searching for case precedents. The firm has now packaged this as a software product which they are selling to other law firms. Then Choice Hotels International, they have a cloud-based reservation system for hotels. They have their own tech and they're actually monetizing it. In a cloud world, you can focus on your strengths. If your product actually becomes good enough, it'll start competing with some offering from some cloud provider. You don't want to be beholden to that same cloud provider. So make sure that you plan for multi-cloud from day one. That's why multi-cloud is key. In a multi-cloud world, any enterprise can monetize in-house tech provided it's good enough. And this brings me to the end of my presentation here. I guess we have a few minutes for questions. If there are no questions, I can talk about the strengths of each cloud platform. Uh, AWS, they are a traditional enterprise, they're the platform of choice for traditional enterprise IT. They're very feature rich, they have lots of migration support and tools, good for all use cases that run well in a virtualized environment, secure applications. They're very mature and enterprise ready. Now, on the downside, they talk of price reductions, but prices on AWS have not really fallen. So it can be a little expensive sometimes. AWS also tries to get to market first with new offerings, and these offerings may not be fully ready with complete integrations. So they might be a little rough around the edges, and you have to be okay with that. With Azure, I mean, if you're an organization who is which is committed to Microsoft, Azure is fantastic. It has good IoT support as well. So often people, if they're building a startup around IoT, they tend to use Azure. Azure has also become more innovative and open, and it has great support for the Linux stack, even though they're originally Windows based. Azure tends to have a few reliability issues, and people seem to be not that happy with the tech support provided. Uh, as far as Google is concerned, they're great at big data, analytics, machine learning. In fact, their data warehouse, BigQuery, is very, very popular. And having used all of the data warehouses across cloud platforms, I feel BigQuery has an edge because they're serverless. You don't have to provision resources. They've also leveraged automation, containers, and Kubernetes well. Kubernetes was originally developed at Google. The Google Kubernetes engine is very, very popular. They have like innovative proprietary software such as Cloud Spanner, that is horizontally scaled relational databases, Bigtable, which I mentioned before. Google seems to be a little immature while dealing with enterprises. They're not really an enterprise company, not enough attention to the boring details. I discussed that earlier as well. Yeah, that brings me to my strengths and weaknesses of the big three. All right, if you have no questions, then maybe I'll just move on to the summary here. Public clouds are here to stay. Make sure that you embrace them. Plan to work with more than one platform in a hybrid multi-cloud world. Avoid the road to perdition. Stay away from vendor-specific products. Don't sweat the big stuff. Be a satisficer and not a maximizer, especially when you're dealing with large flagship products. Sweat the small stuff. The little details matter. Work with your tech support and engineers and actively search for patterns and things that might go wrong. And finally, use the cloud to build niche technology which your company can then monetize.
Jan, it does look like we got some late breaking questions if you have a couple moments.
Sure. What are your thoughts on decentralized cloud storage? So decentralized cloud storage platforms, do you mean like hybrid cloud and multi-cloud? I think so. There's a question here. What are your thoughts on decentralized cloud storage platforms? Now, I think it's not possible for you to move, at least not possible for any organization to move all of their data to the cloud immediately because you might have sensitive data that you want to store all on premises. Now, to avoid the data silo issue, I would recommend that you connect up the data, use some kind of ETL pipeline, so you're kind of summarizing and aggregating the data, transforming it, pulling it to a central location where it's available for analytics. So here's the question. We are integrating services in AWS, Azure, and OCI. One of the biggest issues from a networking perspective is the lower visibility of collecting data like packet captures. Do you see any new service coming that way that may help with that issue? So I can't specifically talk of some new service, but I do feel that cloud interconnects, cloud VPNs, they're the support on the gateway end at each, for no matter what cloud platform you're using, gateways are trying to build in more support so that you have more transparency as to what's going on. So there, even though there isn't a specific feature that I can think of coming down the way, I feel that as you know, I looked at specifically Google VPCs 2 years ago, and about 6 months ago, and I feel that the services that they offered just for monitoring what was going on at the gateway interconnects between networks was much more powerful. Okay, this the next question here is I'm glad you liked the presentation. I have a question on your recommendation on PaaS offerings. It was suggested to avoid PaaS to avoid vendor lock-in. Are there scenarios where you recommend PaaS offerings? Uh, let's say you're going to be multi-cloud anyway, and you're choosing, let's just pick two at random, GCP and AWS, and you really want to use App Engine on the GCP. It's okay as long as you know that you're being locked in and you're kind of making a conscious choice. I would recommend, let's say you have something you need to get to market quickly. Sometimes PaaS is unavoidable, and just like I just know getting something from prototype to production, it makes it so much easier. It's very, very tempting. I would say go for it, but make sure that you're not completely neglecting the other cloud offerings. Make sure that you have services and applications and data stored on your other cloud platform as well, because that will also make sure that within your organization engineers have expertise on both clouds. Because if you just move towards one and kind of focus all your attention on one, then you might lose the expertise in the other as well. So I would suggest, there is another place where I would suggest PaaS offerings, where you know that that proprietary software is really going to help you. And always Cloud Spanner comes to mind. There is no equivalent offering on other cloud platforms. Cloud Spanner is basically a horizontally scaled database which has transaction support across geographies. And AWS and Azure do not have equivalent offerings for like Cloud Spanner on the GCP. So in that case, if that's really going to solve my problems, I would just go with it. And then keep in mind that, this is going to be a problem later. So blockchain based platforms, like, so with blockchain, I do feel that just like machine learning is being democratized, blockchain is being democratized as well. So if you want to get up and running with, okay, firstly, decentralized platforms like blockchain using whatever, whether it's Ethereum or Hyperledger, they make total sense. If you need a decentralized ledger, blockchain is amazing. And in fact, nowadays blockchain is evolving on with cloud platform support to be, you don't have to worry about code. You can use, like, you can just build business applications like with Hyperledger Composer, for example, and use, I would say the easiest way to get a blockchain app up and running is use a public cloud provider. I feel like Azure recently, just in the past 6 months, released a bunch of support for building blockchains on the Azure cloud. And I know that AWS has a bunch of template and cloud formation infrastructure, allowing you to spin up your blockchain network on the cloud. And you can, build your own private networks as well using Hyperledger. So yeah, I feel blockchain on the cloud is far easier to use than, trying to install your blockchains or working with the Ethereum public network. So I feel they they should be used. You can build applications without worrying about the actual ledger details, and they're becoming easier to use as well. Cool. I don't see
Awesome.
any more
Thank you
questions.
so much, Jan. That was a great presentation, very thorough, and we had some really great questions at the end. Just as a reminder to everyone who attended, we will be sending out the presentation in a few days, which will include the slides as well as the recording. Thank you so much.
Thank you.